Hi guys, hope all of us are doing great. In this specific display, I felt it that it's necessary for us to learn different types of waves and perhaps try to have a figurative illustration of what are some of these waves and their properties. So in a sense then, therefore, in this specific case, I'm going to just define a few examples of waves that we are going to encounter in our discussion and some of the parts or anatomy of a wave that I've written on my left side of the display. So in this case, if we try to look at this specific figure that I've given in the middle, it is illustrating two types of waves for longitudinal waves and transverse waves. So the difference between the two, of course, is going to be elaborate whenever I'm going to look at this other side of the board. So we have different types of waves, whereby we're going to see that we have transverse waves, sound waves, and longitudinal waves. And in some cases, we're going to see the cases of electromagnetic waves, which are basically consisting of an oscillating magnetic and electric field. Now, in a sense, if we try to look at this, we're going to heavily rely on this specific lower part of transverse waves, which are going to assist us analyze various aspects of applications of waves, especially in electricity and magnetism, and some other areas that we're going to mention later. So in this case, for longitudinal waves, these are waves that are consisting of compressions and rarefactions. And we're going to see that for longitudinal waves, they are different from transverse waves in a sense that the media is going to move in the same direction as the waves moves. And from this specific case, we can be able to see that this is the arrow indicating the direction of travel. So from this specific case, we can see that there are some lines which are relatively closer to one another as compared to some sections where the lines are relatively further apart. So therefore, this specific places whereby we're or rather specific sections that we're having lines which are together, we can be able to refer to them as compressional or compressions, and these places where the lines are relatively apart, we're going to call them as rarefaction. So therefore, this is an anatomy of what we refer to as a longitudinal wave. And for the transverse wave, this is going to be the ordinary wave that we have normally been discussing in some of our videos. And this is going to consist of a wave that is going to display what we refer to as a motion perpendicular to the direction of travel. And therefore, this is going to be referred to as a transverse wave. Now, in some of our graphing methods, we're going to see that some of the functions, like the trigonometric functions, especially for the sine and cosine of theta, is going to display this aspect of a transverse wave. And we're going to do some of the discussions when we tackle that specific topic. Now, for the case of electromagnetic waves, these are basically waves which are consisting a combination of two waves which are consisting an electric and magnetic field. And as we can see, they are indicated using these particular color codes. For the blue, which is a magnetic field, and the electric field is moving perpendicular to these ones, and both of them are traveling in this specific direction as indicated by this particular arrow. Now, for transverse wave, which we're going to meet especially in a number of our discussions, we're going to see that in terms of anatomy, it's going to consist of different parts. And of course, as we had said that if we try to look at a wave in an essence, it can be defined as a rhythmic disturbance that carries energy through matter or space. Then therefore, it's going to move in a particular or other characteristic way that we're going to define different parts of this one. For instance, we have crests, which are upper parts, and then the lower parts are going to be referred to as troughs. And the distance between one successive part to another one, which we're going to refer to as a cycle, is going to be referred to as a wavelength. Therefore, in some areas, we're going to see that we have different ways in which we can be able to find the relationship between this specific cycle and the energy that is being propagated. As we have said that a wave basically is a disturbance that carry energy. Therefore, we're going to have some ways in which we're going to define the aspect of energy, wavelength, and perhaps the speed of these specific waves whenever we're talking about different types of waves. And apart from these four that I've listed on the board, we're going to have others which, of course, are going to be described as waves and having various characteristics which are unique. For instance, waves which are regarded as sound waves are disturbances which are caused by vibration. And of course, they can be propagated away from the source, also in form of an energy, as I've said for this. So therefore, the distance between the lowest or rather this point of displacement of the x-axis or along the line of travel to the farthest or lowest part can be referred to as an amplitude, which basically is the maximum displacement of or height of a wave from this particular direction of our travel. And then we're going to talk about the concept of a period, which is going to be the time taken to complete one specific cycle, as we're going to see it later. So in this particular case, I hope that we have understood the various anatomy of a wave. And I'm going to put a link of various videos that we have discussed concerning the wave. So in any case, if we need to do a reference, then we can be able to do using this specific video. So that is it for now, guys. Bye. God bless. Catch us in our next video.